rule. It's a composite function which consists of an outer function and an inner function. This was like one of the easiest concepts in the MHF course when we had an outer function and an inner function, and we had to do a number of things to these functions: add, subtract, multiply, but also when we did composite function, we were combining these functions and substituting, right? You will have remembered that. So I'm going to go step by step to explain this chain rule, but the actual definition of the chain rule, the mathematical definition, looks something like this. And really what it means is we are going to take the derivative of the outside function first. We are going to take the derivative of the inside function. And all of that is going to be part of my process, okay? So for some functions, we're going to start off very simple. It's going to be quite easy, but for others, it can get much more complicated. And you will imagine that when we work with radicals, when we're working with fractions, this can really test the process. And it will differentiate when we're marking these tests of what students who are comfortable and familiar working with all types of polynomial functions, and which students can only work with a certain number of polynomial functions, right? That differentiates the marks, as in any calculus course. So instead of dealing with the algebraic variables of a formula, it's so much easier to learn the chain rule with some concrete examples. Now, just to summarize, there are more than this, but our high school course that we have put together due to COVID is going to focus on just these rules. Power rule, the constant multiple rule is just when you have a constant and you take the derivative, it's equal to 0, right? Sum and difference we've kind of looked at for composite functions, but for derivatives, we can take the product rule, the quotient rule, the power of a function rule, and now we are going to look at the chain rule. Just a reminder that power rule, product rule, and quotient rule will be the only concepts that we cover on the test this week. Okay, so we're going to start off with this particular example. F of x is equal to 3x minus 5. I want everyone to take a second, and you know how you would tackle this question normally, so we can compare it with the chain rule. And I am going to stop sharing for 1 second. I'm going to record, share the screen. Okay, so we are going to go step by step through this process for every example in this unit guide or this particular lesson. So first of all, we're going to start off with f prime of x. Okay, and I'm going to treat the outside function as I would x to the power of 4, right? I'm going to treat it like x to the power of 4, the outside function, meaning I'm going to take this, take this 4, bring it in front of the function. Now I have 3x minus 5. I'm going to take the original power of 4, that's my original function, and I'm going to subtract 1 from that. Now that's all you know how to do right now. But because my function inside the brackets is not a monomial, it's a binomial, I can actually, that was taking the derivative of the outside function, as if this was x to the power of 4. But we also have an inside function here. So that's my inside function, 3x minus 5. So now I have to remember to multiply the entire function by the derivative of 3x minus 5. Well, the derivative of 3x minus 5 is just 3. So now what I'm going to do is I'm going to take the 4 and I'm going to take the 3 and I'm going to multiply them together. So f prime of x is equal to 12 times 3x minus 5. 4 minus 1 gives me to the power of 3. I'm going to leave my answer like that because that proves that I've applied the chain rule. Now, if it said to expand fully, then I would take 3x minus 5, I would expand it to the power of 3, multiply it by 12, right? Mr. Bullock is writing this part of the test, so we will clearly indicate if we expect you to expand fully, but my intuition tells me that it's just going to be applying the chain rule, right? He's in the process of writing that test, so we will fully communicate that. Now, let's tackle a question that gives students some difficulty, and that would be a simple radical question, a question with a radical. Now, as always, I'm going to actually rewrite this question as 4 minus x squared to the power of 1/2. That always helps before you apply the derivative rule. So the outside function, and I'm going to write this separately. We want to think of the outside function, how we're going to originally treat this question as, let's say, y to the power of 1/2, right? Or x to the power of 1/2, it doesn't matter, but that's like kind of the outside function. I'm going to, just so that doesn't confuse you, let's change that to x to the power of 1/2. And the inside function is 4 minus x squared. So you want to take the outside function, treat it as what we would do if we had x to the power of 1/2, right? Take the outside derivative first, then the inside derivative. Chain rule, it's a chain. The outside, then the inside, kind of like links on a chain. So this means that g prime of x is going to be equal to, I'm going to take this 1/2. I'm going to bring it to the front. I'm going to take my 4 minus x squared to the power of 1/2. I'm going to subtract 1. I'm essentially applying the power rule. The outside of the function requires the power rule to solve. The inside of the function also requires the power rule to solve. Now, this is where chain rule can get difficult. What if the outside function required quotient rule or product rule to solve, and the inside function also required power rule and quotient rule to solve? Welcome to university. That's what happens in university. But for now, we're starting off very simple. I'm multiplying this whole derivative of the outside. So this is the entire derivative of the outside function. And I'm multiplying by the derivative of the inside function. The constant 4 is 0, right? So negative, if I brought the -1 to the 2, I would get -2. X to the power of 2 minus 1 would give me x to the power of 1. So I'm taking the derivative of the inside. But just because they're separate when we're writing it out does not mean that it cannot be combined. Now let's rewrite this as one more step. So I have essentially 1/2 times 4 minus x squared. 1/2 minus 1 gives me -1/2 times -2x. Now, watch carefully what happens. This negative is related to the brackets only. That means that's going to move down to the denominator. Anything with a negative exponent needs to be flipped, changed to a positive exponent. This 1/2 cancels out with the negative, well, with the 2 at least, in negative 2x. So algebra tells me that I have a negative x left in my numerator, and in my denominator, I have 4 minus x squared to the power of positive 1/2, which can be written as the square root of 4 minus x squared. It is your choice. You could have made that 2 steps or 1 step because I'm just explaining it verbally. So we went from calculus to something that an MCR student would be tested on, right? Hand in hand, these math concepts go hand in hand. I'm going to also show you a chain rule word problem, but we're going to go into now 2 complex chain rules. We have dealt with 1 square root. Let's deal with multiple square roots. And it is my, I've been teaching calculus for many, many years. And it is my experience that when, especially in regular Mary Ward, when you have a seminar and you jam 1 hour of chain rule, students get very scared because it's very easy to show you difficult applications of chain rule. So this is what I'm going to do. I'm going to show you bit by bit by bit. So today we're going to do 2 more examples, a little bit of a word problem, and then I'm going to release you to do lots of practice, okay? The more practice you do, the less scared you will be. If I spent a whole hour and a half just drilling you with example after example, your anxiety and your fear about chain rule would go up. There's a reason why we're giving you so much time to study for this test, because we know it takes a time to wrap around this chain. Essentially, we're going like this: outside, inside, outside, inside. And some chain links are more difficult than others. So that's how you want to tackle it. And when you have problems with the questions, we're more than happy, especially when you are all virtual next week, to solve particular questions. Or if you say, Miss, this question in the unit guide is really bothering me, it really is, I find it challenging. It's very simple for me to make a 2-minute video or go over it in class with everyone, right? So don't be afraid when you come across a hard question. We are experts at calculus, so Mr. Bullock and I are more than happy to go over this stuff with you. Okay, and we're going to take a deep breath. Now we have more than 1 square root, so we're going to tackle them slowly, one at a time. Okay, first I'm going to tackle, what do I want to tackle first? The first term. So I'm going to do dy over dx, and oops, what happened there? Let's try that again. Dy over dx. I'm going to bring the positive 3 down. I'm starting off with power rule, chain rule. Chain rule that involves power rule first because it's the easiest kind. We're going to give you lots of examples over the next couple of days. So then I have my 2 root x to the power of 3. I have to subtract 1 from that. But I also now, usually I would move forward at this point, but I also have to take the derivative of this inside before I move on. So the derivative of the inside, now if I have 2x to the power of 1/2, that is my inside, right? If I take the derivative of that, I'm going to be left with dy over dx is equal to 1/2 times 2 times x to the power of 1/2 minus 1, right? So that derivative of the inside can also be quite complicated. I don't need you to show this on the test. I just need you to show in the chain rule that the answer to that is x to the power of negative 1/2. That's the derivative of the inside. So this can be shown on scrap paper. You can work it out, but you can see that if you get the inside wrong, the answer, it's impossible to get the answer correct. So you need the correct derivative of the outside as well correct derivative of the inside. This is the beauty of short answer over multiple choice. Because if I only gave you a multiple choice test, you only have one shot. And a question like this probably would be worth 3 marks, but you would either get 3 or 0. Yeah, like if it was a multiple choice. If I give you a short answer question, I can make this worth 4 or 5 marks. Even if you make a mistake, I can still give you 2 or 3 marks, right? That's why as a teacher, I really appreciate short answer over multiple choice. Okay, now we're moving on to -4 root x. Now remember, that's the same as -4 x to the power of 1/2. So when I take the derivative of that, I'm going to bring down the positive 1/2 multiplied by -4. And then I have x to the power of 1/2 minus 1. Okay, now what do I do with the positive 1? The derivative of any constant number is 0, so I can immediately ignore that. Rewrite this a little bit. Notice that there is no inside function here, right? The -4 root x is just a straight apply the power of a function rule. There is no inside function, so there is no chain rule that I have to worry about. So the only chain rule portion, oh, didn't want to do that. No. Okay, 3, there we go. Okay, let's again. The only chain rule portion is this. Okay, so I'm gonna, before I move on, I'm gonna simplify a little bit. Okay, I did make a mistake here. No, I didn't make a mistake. There we go. 2 root x, 3 minus 1 gives me 2 root x squared. And multiplied by this x to the power of 1/2. Again, this is all the chain rule. I've just simplified it a little bit. And then I have to take into consideration this. 1/2 minus 4 is -2, x to the power of -1/2. So it takes all the steps you need to make sure you're not missing anything. At this point, I'm going to combine 2 root x squared would be the same as just 4x. Then I have x to the power of, and sorry, this should have been -1/2. So x to the power of -1/2, then minus 2x to the power of -1/2 as well, combining 3 and the 4x. So I can do piece by piece, choosing what I combine piece by piece. I have 12x times x to the power of -1/2 minus 2x to the power of -1/2. Now, when we solve completely, if we combine our like terms, so remember, for this part, the product, right, would be, you can add the exponents to solve for this. I'm going to extend my page. I'm going to write down the final answer so that you are able to work with this more complex question, to simplify it, to try to see that if you can get this question in simplest factored form using your knowledge of MCR. Okay, I'm going to task you with that, because I do want to now move on to a product rule, chain rule question, which we're going to focus on quite a bit in the next lesson. So I'll give you a second to write this question down. X squared plus 3 to the power of 4. So I have to do my outside derivative to this one, as well as my inside derivative for that question. Again, for 4x minus 5 to the power of 3, I have to do the outside and the inside. So I have to do chain rule quite a bit. This is an h of x function. So I'm going to say that h prime of x. So the outside of 4x squared plus 3 to the power of 4, I'm going to bring down that 4. It's the x squared plus 3 to the power of 4 minus 1. And I have to multiply that all by the inside function, which is going to be 2x. Now, that is the derivative of the first function. So remember our product rule, derivative of the first function times the original second function. So my original second function is 4x minus 5 cubed. So not only am I applying the chain rule, I'm also applying the product rule. The second part of the product rule, remember product rule is always a sum, right? A sum derivative. So now I'm going to take the derivative of the second function. That's what the product rule tells me to do. The chain rule tells me I have to bring down this power of 3. I have to take 4x minus 5 to the power of 3. I have to subtract 1 from that. Then I have to take the inside. So the inside of 4x minus 5 is multiplied by 4. So all of that is chain rule. But I have to remember my product rule now. And the product rule tells me to multiply the derivative of the second function by the original first function. That's why we're making this entire test about power rule, product rule, quotient rule to really drive those concepts home. And you're studying those rules. So now when we apply the chain rule, do you see how complicated that looks? But you essentially apply the product rule and marry that with the chain rule. Okay, so let's combine now. H prime of x. Well, if you're given a possible x value, you could just plug it straight in, but we can also look at greatest common factors. So notice, I'm going to use my highlighter tool right now. Let's check the highlighter. There we go. So the highlighter tool I'm going to use to highlight greatest common factors. Notice we have an x squared plus, oops, that's not what I wanted to do. X squared plus 3. Forget the power, but we have an x squared plus 3 that is common. We also have a power of 4 that is common. And we have a 4x minus 5 that is common. So first of all, I'm going to rewrite the question without all these, making sure all the powers are calculated. So I have 4x squared plus 3 to the power of 3 times 2x times 4x minus 5 to the power of 3. Now plus 3 times 4x minus 5 to the power of 2 times 4 times x squared plus 3. Next step is I'm going to take the greatest common factors out. Now the common factor is going to have the lowest power. So I'm going to use that highlighter tool again in a different color. And I'm going to highlight. Nope, didn't want to do that. I'm going to highlight my power of 4. in both scenarios. I'm going to try to highlight my x squared. I don't know why it's doing that. Okay, there we go. So basically, I'm highlighting all the greatest common factors. I'm going to highlight. Smartboard is just playing tricks on me today. The x squared plus 3 to the power of 3, because that is the lowest power. I am missing something here. I forgot to write this power of 4 there. So I'm always highlighting the term that has the lowest power. So the power of 3, and then 4x minus 5 to the power of 2. And I'm going to, using my highlighted terms now, I'm going to rewrite this question. Go back to our pen tool, and there we go. So I'm going to have h prime of x is equal to, with the greatest common factor, I have 4 times x squared plus 3 squared, 4x minus 5 squared. When you take that out, the greatest common factor out, you're left with 2x times 4x minus 5 plus 3 times x squared plus 3. So all that's left to do now is expand the square brackets, So h prime of x is equal to, in black, is my greatest common factor. And by simplifying my square brackets, I'm left with 11x squared minus 10x plus 9. A lot of algebra. That's why we don't need you to graph questions when it comes to derivatives, because there's a lot of algebra involved. And a reason for that, because for STEM careers, programming, calculations, optimization requires lines and lines upon lines of algebra or, hypothetical math. So linear matrix, there's so many things. So we are starting in calculus to get you used to these multi. You thought we knew what multi-step was before, but calculus really teaches you, this is what we mean by multi-step equations. Okay, so we're done writing for today. I'm just going to walk you through a possible application question to this. So I have a slide where, which is written out a little bit nicer, but it's the exact same questions that I'm doing. So if I bring down the screen for this, and I'm going to turn this into a full screen. Okay, so if we had a function, we had to apply both the product rule and the chain rule. We know that's the chain rule because in 1 minus x squared, the second function can be, you need the chain rule to calculate the derivative of that. But we have a specific value at x is equal to 0.5, just like we've been doing. So of course, this is going to show up on the test. Find the equation of the tangent line, right? So first we get the point of the tangent line by substituting 0.5 straight into that original equation. So the point on the tangent line, please don't confuse. It's always the original equation, not the derivative equation. That's why I always make that my step 1. My step 2 is calculating my derivative, which will give me the slope of the tangent line, not the equation of the tangent line. That is another mistake I've seen on many calculus tests over the years. It is not the equation of the tangent line. The tangent line is a linear equation. So we take the derivative using the chain rule. So obviously we, the chain rule, and the product rule. So the derivative of the first function times the second function plus the derivative of the second function. And the derivative of the second function requires the chain rule times the first function of 3x. That requires some expansion. So we expand as much as possible. We can take and see that there's a greatest common factor of 1 minus x squared that we need to factor out. And when we factor the 3 times 1 minus x, we can get this. Now, the easier or a nice part of having a specific x value is even if you didn't get to this line here, maybe you got into this line, if you substituted x into that, either one of those equations, you're still going to get the slope of the tangent line, okay? So we can be a little bit more lenient in our marking there. So we're substituting the 0.5 straight in, as long as your equation is calculated correctly. I don't even know how I did that. So then my slope of my tangent line at x is equal to 0.5 is -3/4. Now, the equation of that line, we're plugging in the y coordinate of my point, x coordinate of my point, and slope. Plug in the -3/4, we plug in x is equal to 0.5, y is equal to +3/8. We get b is equal to 3/4, so that gives me an equation of the line. And if you need to see that, we have a curve that resembles a cubic, but it's a polynomial function. And at x is equal to 0.5, you can notice there is a tangent line to that curve. In the future, we're going to use tangent lines to talk about optimization, the optimal point, the point that will give me the best result. Tangent line does not mean that it doesn't cross the curve at other points. It is just a tangent that specific important point that is important to that curve. Okay. Yeah. No problem. So that's important to that curve. And now that we know how to get the equation of the tangent line, you're going to be able to take that concept and apply it to more relevant calculus that will be used for multiple real life applications for as long as you're required to take math courses in any program that you go to.